Okay, we are ready for going over the answers for worksheet 2-C. And yeah, this is not really going to get you extra points on a test for an answer like that. Anyway, and yes, I did give problems like that to my Honors Math 3 classes. All right, let's start with number 1. Let f of x be this, h of x be that. Describe the transformations to h of x in terms of the parent function. So f is the parent function, and we have done several transformations to this guy. So we're going to talk about this is going to stretch it vertically by a factor of 2. That is going to go not to the left but right 4 units. Remember, we're still doing it backwards like this. The only time we don't do it backwards is when there's a negative x in there, and then we do backwards. But anyway, if that makes sense, hopefully it does. All right, and then this guy, that is a nice straight arrow, and then we're going to go up 6 based on that guy. That was the first one. Describe the transformations in terms of the parent. I will note that there were a number of you that missed a problem somewhat like that, because when I gave you the first function, it wasn't a parent function. It was like square root of x and then plus 1. And a lot of y'all forgot to take into consideration that, yeah, there is something extra already happening to it, and then I'm going to transform it on top of that. And so it kind of knocked off your answer a little bit. Some of you caught it, some of you didn't. I had probably 4 or 5 people that tried to remind me and hit me on remind and say, Mr. G, none of these answers work. I said, go back and look at the problem. Anyway, all right, write a piecewise function for this beast. All right, so we'll start with this guy here. Let's make him green. And we notice that he is going not up and over. In a sense, this is a negative slope, which means that he's going down 1 over 1, down 1 over 1, down 1 over 1, and he goes through the origin. So we're going to write our function notation, and then we're going to start with the first one and say this is negative x, negative 1x really, but negative x plus 0. We might as well just leave it as negative x. And this is for all x's that are less than or equal to 0. Since there's a dot, there was a dot down there. Well, considering that it wasn't an open circle, we'll assume that it's a dot. All right, let's do this guy next. And he is on a straight line where y is negative 2. So that is going to be negative 2, y equals negative 2. And that's going to be from 0. 0 is less than x is less than or equal to, and that is 1, 2, 3, 4. And then we'll finish out with the blue guy. He is going up 1 over 1, up 2 over 4. He hits it right there. So this is going to be the square root of x. And since we've moved the vertex 4 units to the right, we're going to say minus 4, doing the opposite. And that is for all x's that are above 4. That's what that should look like. Now, find the range of the piecewise function below. Wow. What we kind of need to do is, since we don't have a graph to work with, we're going to take these one at a time, and we're just going to do a t-chart. and we're going to do where x is 0 and where x is 2. Because our top and bottom of the range should be happening maybe at one of those. So when I stick a 0 in there, 0 minus 4 equals -4, and 2 minus 4 equals -2. Now I will note that this is an open circle, just in case we need it later on. And then we're going to pick up the next one, this guy. And we're going to go from 2 to 4, and there's an open circle where 4 is, less than. All right, so when I stick a 2 in there, 2 squared minus 3 times 2 plus 4, that's 4 minus 6, that's -2, plus 4 is 2. And then when we stick the 4 in there, 4 squared minus 3 times 4 plus 4, that's 16 minus 12, that's 4, plus 4 is 8. And then we're going to try the last set down here. Oh, well, that's going to be kind of easy. When x is 4, y is 5. When x is 7, y is 5, and this is an open circle. Now, the lowest that we've ever seen it get is down here. The highest that we've ever seen it get is here. So our range is going to go from -4, and I don't have an open circle there, so I'm going to do that. And my 8 does have an open circle there, so we're going to do that. And these 5s don't even come close to touching it, and neither do these guys. And I mean, if you were wondering if it possibly could get higher, you could, do 3 in the meantime. But you're going to find out that 9 minus 9 plus 4 is going to be 4. It's not going anywhere. You could check that if you were worried if somebody in the middle might be higher. But that's probably the quickest way of doing the range. You would need to plug these in. If they asked you about the domain, the domain is all of these guys up here. And the domain of this would be from 0 up through open circle 7. That would be the domain. So anyway, they do love to ask you about domain and range on these weird ones, don't they? Well, it only gets worse. All right, lateral surface area of a right circular cone, S, is represented by the equation pi r times the square root of r squared plus h squared. Wow. Let's just say when I taught geometry, r squared plus h squared, and the square root of that is another fancy way of trying to figure out the lateral height, or excuse me, the slant height of a cone. Because I will take the opportunity to use a teachable moment here. But inside the cone, you've got the height, you've got the radius, and then you've got this thing over here called the slant height, which they usually will use like a cursive L or sometimes a lowercase l in italics. When I try and do that with handwriting, people think it's a 1, so that's where I start doing the cursive L. But anyway, pi times the radius times the slant height is basically what they're after here. All right, so if we're taking that formula and the lateral surface area, our S is that, and the radius is that, find its height to the nearest hundredth of a centimeter. So we plug everybody in. We say 364.25 is equal to pi times the radius 575 times the square root of 5.75 squared plus h squared. So now our job is to get h by itself. Oh boy. So, before we can do anything with h and get it out from underneath the square root bar, we've got to get the square root by itself on that side of the problem. So our first step is going to be to divide both sides by pi and 5.75, and divide this side by pi and 5.75. All right, let's see what Mr. Calculator says. Okay, my calculator is telling me 20.164239. So one of the questions that's a good one to ask here is, where should I round this thing? Now, we are in the middle of the problem. And when we get to the end of the problem, we want the nearest hundredth of a centimeter. That would be 2 decimal places. All right. My rule of thumb is this: if you're going, if you're still in the middle of the problem, there may be what we call rounding errors, where you round something and then you run it through another equation again, and your answer starts to drift a little bit. And it's not quite the exact answer. And sometimes it shows, sometimes it doesn't. One of the ways that we can make sure that we will never see that drift show up is to round it at least 1, maybe 2 decimal places beyond what's required. Now, it's the nearest hundredth, there's 2 decimal places. I think I'm going to round this to 4 places, which would be 20.1642 equals square root of that. Now, I'm going to go ahead and figure out what is 575 squared. Let's not waste a whole lot of space doing itty bitty steps. So it's 33.0625, and again I'm going to leave it in 4 decimal places because I don't want my rounding error to cause my answer to drift in a way that I'll notice. Now, if we're going to get the h out from underneath this, we're going to have to square both sides. We're going to square this and square that. And so what we're left with is this and that. And then when you've already got the 20.16 in your calculator. Hopefully, you've still got it there, and you don't have to, if you just want to square that number, then you really don't lose anything. You don't run the risk of, but I tell you what, I'm going to, because I've already done something else and I'd have to go back and retype the whole thing over again. I'm going to do the 1642, and I'm going to square that. And we get 406. Now 59496. I only want 2 more places, so I'm going to call it 50496. The 6 bumps the 9, the 9 bumps the 4. And so instead of 49, it's 50. All right. Now I'm going to subtract this guy right here. And the funny thing is if you keep this, a couple of extra decimal places like that, you might be surprised at how the answer turns out. Subtract 33.0625. Calculator says, I will bring it over here, 373.53246. I'm going to call it 5325. And of course, at this point, once we start rounding, I'm going to start doing that, which tells me these are not exact answers. These are approximate. And I want to take that 373 number and I'm going to square root it. Second square root, second answer, enter. And I don't exactly get, well, they said to the nearest hundredth, that's 2 decimal places. So I'm technically getting, if I were to do this to the same 4 decimal places, and so I'm going to round it to 2 decimal places, which that 2 has got to round up to a 3. And that should be the approximate height of our cone. Okay. Now, let's see, now we got 3 more of these. I'm going to pause here and do the other half in the other video.